Hey everyone, welcome to Tutoring. I hope you're having a great day because today we are doing a topic video on parametric equations, which should be chapter 1 of your textbook. This should also be your holiday's homework, so hopefully this video helps you complete that holiday homework of yours. Right, so let's get into the video. What is a parametric equation? A parametric equation is a pair of equations that has three variables in the special course. So that would be x in terms of t, and I'll give you the simplest example here, x equals to t, and then you have another equation, like I said, a pair of equations, so that's one of them, x equals to t, and then we have another one, perhaps y equals to t as well. So there we go, you have a pair of equations with three variables, x, t, and y. In the special course, what the textbook, your teachers, and the exam wants you to do, especially in the exam, very important, is you'll have to convert these pair of equations into one Cartesian equation, which has only the two variables y and x as per your normal equations. So that is called a Cartesian equation. You'll see that quite often. Okay, so how would you convert these pair into one? Very simple. We know that x equals to t. We also know that y also happens to be equals to t. It's pretty logical. Y equals to t, t also happens to be equals to x, so therefore y equals to x, and that's pretty much it. That's how you convert a pair into one. Y equals to x. So you want to get rid of the t, the time variable. So the good thing about parametric equations is it introduces a real term, like a real variable, so that is time, into your typical 2D plane maths equations, which is quite nice. You'll see this a lot in the exam because the exam likes to introduce your real life applications into it. So a lot of time variables in there, okay? So this is very simple. Y equals to x. There's much harder examples out there, but we'll stick with this and we'll introduce a domain for time because, as you know, time cannot be negative. So our domain for time, let's just say, shall be 0, and maybe we only want up until 10 seconds. It can be minutes, hours, it doesn't really matter. But in this case, we'll use seconds because in the special course, most of the units you use for time would be seconds. Right, so time can only be from 0 to 10. So let's imagine we have an ant called Anthony right over here. I don't know how to draw an ant, but I know it has many legs. So there we go, that's its head and that's its legs, okay? And it's moving in accordance to this pair of parametric equations. So x equals t and y equals t. We want to know from 0 to 10 seconds, where would Anthony be, okay? So at time equals to 0, let's position him in a axis, but at time equals to 0, x, what is x equals to? Well, it's pretty clear here. At time equals to 0, x is equals to 0. And at time equals to 0, y is also equals to 0. So Anthony essentially starts at the center. If we were to have an axis right where Anthony is, and he is positioned at the origin in this case, okay? So that's where Anthony is, at the center, at the start, okay? At the start, he's at the center, 0, 0. Okay, so this is where parametric equation is actually quite useful, so it's really good. Now, after 1 second, where is Anthony moving? So after 1 second, we sub t equals to 1 over here, so t equals to 1, we get x equals to 1, we sub t equals to 1, we get y equals to 1. So after 1 second, Anthony is over here, which is quite nice. So he doesn't move. Imagine this is your piece of paper, right? He's starting at the center of the piece of paper. After 1 second, he moves over here. So we know he's definitely going from the center to the top right, so quadrant number 1. And then he just keeps moving on. So after 10 seconds, he'll be somewhere here. We know his path, the model of his path would be along this line, the straight line, which happens, if you want to find the equation of the straight line, it is y equals to x. So that is pretty much parametric equation. It's quite nice. It models a path or a movement of an object, a particle, and it actually gives you an equation for it. And I'll provide you with a more common example. X equals to cos t, y equals to sin t. Right, so that is still a parametric equations. We've got a pair of equations with three variables in it, x, t, and y. Right, now you want to convert this into a Cartesian equation. That means just one equation, getting rid of t. How do you do that? Well, as you learned in methods, there's something called the identity rule where cos square of t plus sine square of t equals to 1. And As you can see here, the t disappears, it becomes 1. We can do the same to your pair of equations. So in that case, we only see squares here, we square both sides of the equations. We get x squared and we get cos squared t. You do the same thing for y, you get y squared and you get sine squared t. And we know that cos squared plus sine squared right here equals to 1. If you add them up, they equals to 1. So therefore, it only makes logical sense that if you were to add x squared and y squared up, so x squared, y squared, they should equals to 1 as well. And there you go, x squared plus y squared equals to 1. There's no more t, that is one equation only, and that is a circle with center 0, 0 and radius of 1. That's why we learned ellipses, hyperbolas, and circles first before moving on to parametric, because this parametric equation topic right here uses a lot of circles, ellipses, and hyperbolas. And yeah, if you want to sketch this graph, very simple, but I'd like to introduce another concept which makes parametric equation a headache, and that is, once again, the domain, right? So over here we have domain t from 0 to 10. I would say in this case, let's just say 0 to pi, okay? So my time can only be from 0 to pi. Where can Anthony once again move if he's restricted to only from 0 to pi? So we stop recording his movement after 3.14 seconds, okay? So if you want to do that, guys, so let's start with our axes right here. We know it's going to be a circle, so you can draw a circle first if you want. We know it's going to be a circle with center 0, 0 and radius of 1, okay? Oop, draw my best impression of a circle. There you go, 0, 1, 1, negative 1, negative 1. Just remember, Anthony cannot be at the center, he has to be on the circle. He starts from somewhere. If you want to know where he starts, what you can do is you can sub in the time equals 0 into your pair of equations. So if we sub in x equals to cos of 0, what we get is 1. And if you sub in y equals to sine of 0, what you get here is 0. So where Anthony starts is right here. X equals to 1, y equals to 0. There is no time variable, okay? There's no time variable on your graph, so there's no time. You don't have a t equals 0 anywhere on this graph. Just position your x and your y, and that's it. So he starts over here, and you want to know, okay, where does Anthony move? He can only move in one direction, right? Either clockwise, so he can either go clockwise right here, or he can go anti-clockwise in the other direction. Right, if you want to determine where he goes, there's two different methods, and I'll show you the easiest, the quickest one possibly, and that is you sub in another time very close to 0, okay? But because we know this is a trig equation, you need to sub in something with a pi so that you can solve for it if this was tech-free. Right, so maybe you can try sub in pi on 4, cos pi on 4. So sub in something very close to 0. I'll show you why you want to sub in something close to 0 and not something maybe like a random pi out there. So not like pi maybe, but let's just sub a number close to 0 first. Cos pi on 4 would give you 1 on root 2 or root 2 on 2. So root 2 on 2, and then y equals to sine pi on 4. That should give you root 2 on 2 as well. Okay, so this is positive, that is also positive. We know it's in the first quadrant, so pi on 4 is in this quadrant. Pi on 4 is actually really close to 0 because that's 3.14 divided by 4, which is less than 1 essentially. And we know that time gives us a positive quadrant. So we know Anthony is probably positioned somewhere here, maybe in the middle, we don't really know. But he's positioned somewhere here in the circle in the positive quadrant at a time close to 0. At 0, he's here. At a time very close to 0, he's here. So there's only one logical movement for Anthony to be following, and that is going anti-clockwise, okay? So going this way, right there. And if you want to confirm, if you're really suspicious, like, you're not absolutely sure, maybe, he moved really fast. He went all the way over here until here in a span of 0 point something seconds. If you want to be absolutely sure, you can sub in another one, x equals to pi. So x equals to pi over 2, my bad. So x equals to pi on 2, y equals to sine pi on 2 as well. T equals pi on 2, my bad. Cos pi on 2, that would give you 0, and y equals sine pi on 2, that would give you 1. And as we can see, after pi on 2 seconds, Anthony is over here, okay? So he moved, it's only logical, he moved pi on 4 over here, and then pi on 2, he moves to here. It's not reasonable to suggest that he moves pi on 4 all the way, going clockwise all the way here, but then at pi on 2, he comes back here. That doesn't make sense, okay? So in this case, guys, because we are restricted to pi, so you have to sub in pi as well. Make sure you sub in all the endpoints. So a lot of subbing in, but logically you didn't really have to sub in the pi on 2. This is just to make absolutely sure. X equals to cos of pi, sub in our endpoint so that we know where Anthony stops. Sine of pi. Right, so cos of pi is -1, sine of pi 0, so Anthony stops over here, okay? So he starts at 1, 0, and he stops at -1, 0, because we know he moves in the anti-clockwise direction. So all the way up until here. And this bottom half of the circle is not included in his movement from this time period, okay? So this is where majority of students get parametric equations wrong. You cannot, under this situation, sketch this part. So you have to cancel it out. So get an eraser, rub it out, make sure you only draw the top half and put a direction as well, okay? So that is pretty much it for your parametric equations. Make sure domain, always have a look at it during your reading time, or just, always take notice of your domain. Aside from that, guys, that is parametric equations. And thank you for watching, and I'll see you in the next video.